class, and welcome to part one of a two-part lecture on conceptualization and measurement. This relates to chapter 5 in your textbook. So, as you know by now, your textbook tends to include, a particular study or a program of research in each chapter that's emblematic of what it is they're focusing on. In this case, they talk a lot about the research of Ed Diener and his colleagues, as well as some other researchers who are looking into this idea of how do we measure the concept of happiness, this construct, this hypothetical construct of happiness. So he generates, this scale called the Satisfaction with Life scale, the SWLS, as part of his research beginning in the 80s. And it really came to prominence in the research world as a good objective measurement of people's subjective happiness. And in the book, they give you examples of questions that are asked to compute a total score for general satisfaction. So it takes this very subjective, abstract concept of happiness and converts it into a numerical value that you can then use as a dependent variable, as something to investigate people's happiness in an objective way and compare one person to another in a meaningful way, including statistically. So this is the technique they're utilizing, but essentially it's a good example of how we're starting with something very hypothetical and an age-old construct or question of what is happiness. And in the positive psychology world, which is this recent development of the last few decades, is using these types of measurements. They're trying to get into something as subjective as happiness, but they want to understand positive psychology and how it relates to that. So they have to find ways to measure it. And this chapter is all about how we go from a concept to actual objective measurement. So this is that process of conceptual definition into operational definition that we're going to spend some time discussing. We'll be coming back to Diener's research throughout, as well as some alternative examples of ways to measure happiness as we go along. So, as you remember from our previous lectures, we really start with philosophical or psychological questions at this conceptual level or construct level. I'm going to use the term concept and construct interchangeably. But remember that a construct is an idea, a concept, an abstraction, and it has multiple references that are measurable within psychology. So the construct itself does not exist in the real world as a material entity. It's cast within a psychological theory which provides a conceptual framework to study a topic. In this example, happiness is what we're talking about. So constructs are specified in a theory to those purposes of science we've discussed in the past. That's what they're really aimed at, describing, explaining, predicting, and potentially controlling human behavior, human psychology. There's an example from your book from 2007 by Corey Keyes where he defined a conceptual construct of mental health, for example. So when we say someone is mentally healthy, how do we operationalize that? And he studied it from a clinical perspective. He looked at things like, are you reporting any negative affect, things we associate with quote unquote abnormal psychology? The absence of those things was therefore thought to represent, objectively mental health. Now, of course, that's sort of coming at it from the opposite side, right? Looking at the other side of the coin. If there's an absence of negative emotion, then we must assume that person is experiencing some happiness. That's an interesting way to approach that concept and define it, whereas Diener really comes at it from this idea of subjective well-being, which is going to come back throughout the chapter. So we have various methods of measurement. And we need to understand how we get from concept to operational definition and measurement. So we've used the term variables before, and essentially variables represent the constructs that are under study. But no one variable fully defines a construct, and that's really important. We always make a choice. We have to select one particular angle or aspect, or sometimes we try to be very holistic and capture as much about the construct as we can, but ultimately we're making subjective decisions in how we operationalize this thing. So it never fully captures the entire construct. All measurements are essentially to some degree imperfect in that way. This is almost like going all the way back to Plato, right? And the idea of the forms, the objective reality that we can never quite really touch or see or perceive, but rather we just kind of get these reflections of it in the real world, these sort of instantiations of those perfect forms. Well, in a certain way, we have to say Plato's kind of right. This idea that something that we've created cerebrally in our brains, this agreed upon construct like happiness or mental health, we can never truly touch it, measure it, examine it. We have to sort of find ways of getting at it that are all somewhat imperfect and all include, some potential bias at all time, and that's an issue. But essentially, what measurement is doing is it's allowing us to answer the question, do these hypothetical constructs reflect some objective reality? One thing we do to try and get at the construct more effectively, to try and get a more, like I said, more holistic picture of it, is we use multiple methods. This is really essential in order to develop a more complete understanding of any phenomenon. So you have to be able to come at it from various different angles. I'm not sure if any of y'all are familiar with the old parable of the blind man and the elephant. And there's this idea. It's an old. I think it was developed in India, but you have a group of blind men that are out on the street, and they come across an elephant, and they each start examining the elephant, by touching it because they can't see it. And so, one touches the trunk and says, well, this animal, the idea being presumably they've never encountered an elephant, and he says this animal must be like a snake, it has this long sinewy body. The other touches its feet and says, oh, this animal must be very much like a tree with thick, heavy skin and very weighty, dense legs. So they all touch it in various different ways, and they all have different perceptions of what it is. So the idea is that if we come at it from various angles, if we utilize multiple methods of measurement, we're hopefully going to capture at least some sense that this is an elephant, and it has all these components, and we're getting a fuller picture. So to illustrate the idea of multiplicity of measures, using multiple methods for measuring things, the authors of your book provide some additional examples of how some researchers have studied the idea of happiness, or in this case, we're going to use the term subjective well-being. Happiness is a bit too abstract for psychologists, right? We have to put some other sort of label on it. So the term that kind of is really largely agreed upon within especially the positive psychology research world is subjective well-being. But when you hear that term, I want you to associate it with what we generally think of as happiness. So there's a couple of examples that they have. So we started off by mentioning Diener's satisfaction with life scale, the SWLS. These are two other methods that have their own abbreviations. There's one called the experience sampling method, which is developed from personality psychology researchers. And this is where the person provides a record of their current circumstances and the feelings that they are experiencing in real time. So the idea is that at certain points during the day, either in a structured way or in a random way, the person is asked to make some report about what they're experiencing in real time. And the idea behind this is that it's going to be a good, accurate measurement, or a decent measurement of subjective well-being, because you're getting people while they're engaged in their everyday lives. You're trying to avoid sort of coloring that comes with reflection and reenacting things that have happened a while ago, the destruction of memory over time, that kind of thing. As you can imagine, this can be done utilizing some interesting technology, that wasn't available maybe 20, 30 years ago. So for example, in this one study that was done by Killingsworth and Gilbert in 2010, they recruited a little over 2,000 adult participants, 2,250, and they would have them receive an iPhone signal at random times. They would install an app on their phone, and it would ask for an immediate reply to three simple questions. There was what's called the happiness question: how are you feeling right now? An activity question: what are you doing right now? And a mind wandering question, which is, are you thinking about something other than what you are currently doing? Now, you might think those first two questions are very obvious. Superficially, they make sense, right? They're valid on the face. But why that third question? Why the question, are you thinking about something other than what you are currently doing? Well, when you realize that this is important enough to be one of the three questions that these researchers are asking, then it tells you a little bit about their construct of happiness, how they're thinking about happiness, right? They're showing their hand a little bit to us, even the people that are participating, in what they think happiness is related to. And as you can, glean from or infer from that question, what they're finding is they think that people who are being present, which is a really important concept from acceptance and commitment therapy in the clinical psychology world, this idea of being in present focus, being in the moment, being here now, rather than in your mind reflecting on the past, mulling over thoughts, or projecting into the future that's not here yet. Are you present in the moment? They're positing that being present is one way to increase your subjective well-being, rather than living in the past and focusing on past things or worrying about the future. So their results did indicate that people that spend considerable time with their mind wandering tend to be more unhappy, as opposed to those that are able to engage and actively be present in what it is they're doing. Another method that's discussed in the book is the research by Kahneman et al. Remember, et al. Is just an abbreviation for a long list of authors. You name the primary author and then you use et al. After you've referenced it once. This is a study from 2004, and they use something called the day reconstruction method. And this is where you have the person sit down with sort of in a diary form and reflect upon the preceding day. In this case, it's divided into episodes, it's broken down into chunks, and then they describe each episode utilizing, some questions about subjective well-being. In this study, they took 909 employed female participants. It was a pencil and paper measure, and involved journaling utilizing this structure. And the results were actually similar to the ones from the experience sampling method. What they found was that people that were spending more time engaged actively with whatever they were doing during that day, as opposed to sort of living in their own head or having their mind wander or being unfocused, that those that were more focused and present tended to report higher levels of subjective well-being. So now, between the day reconstruction method and the experience sampling method, and then Diener's satisfaction with life scale, we have three methods of getting at one construct, right? Multiplicity of methods, hopefully giving us a better, accurate measurement of this construct that we're interested in, happiness or subjective well-being. So we have to go through a process in developing a research study, in any research study, or in developing a theory. We have to go through that process of taking the theoretical, the hypothetical constructs and operationalizing them, right? Turning them into something measurable, turning them into something objective that we can look at, not only so that we can get an individual understanding of what that person is going through, but so we can compare them to one another, and almost always in a statistical way. So each of these three approaches provides a different and distinct operational definition of the construct of happiness or subjective well-being. You consider that the data and the variables analyzed in the ESM, and they were using that satisfaction with life scale as well, and the DRM studies, the construct of happiness or perceived well-being is operationalized in different but meaningful and measurable ways. Right? We're coming at this, we're examining other parts of the elephant. We're trying to get a larger picture, and we're trying to have a more general and holistic understanding of the construct. So the significant point is, is experienced well-being and life evaluation. These represent two components of this larger construct of subjective well-being, and we assess them and operationalize them using different methods, which underscores the critical point, which is that no one variable can fully capture the meaning of a construct. I want that to really stick with you. We're never getting a perfect picture. If you're standing on top of a mountain, you have one understanding of what the mountain is. If you're a mile away, you have a very different understanding. Which of those is right? Which of those fully captures the mountain? Well, neither does, right? Your perspective matters, and how you're looking at the thing. So these are just choices that the researchers are making. These are options that they're utilizing to measure, and usually those decisions are driven by their theory, by the way they think about the larger construct of happiness. So, for example, the ESM, this method we mentioned earlier, it uses a sampling of moments, and it assesses how people sort of evaluate their lives and their general satisfaction. The DRM is this assessment of these contiguous episodes over a full day, and it assesses more of this experienced well-being. It's really asking the person to try and put some numerical value on how they're feeling in terms of happiness. And as I mentioned in the previous slides, there's a lot of advantages to multiple methods. Which method you use, which variables you choose to focus on specifically, is really going to be matched to what your research question is, and arguably to your underlying theory, your theoretical construct you're using to understand whatever this thing is. So the variables that you think are important in the process are the ones you're going to focus on. So you want to try and utilize these multiple methods to get a more general understanding of a phenomenon. You often see this even within an individual's research program. And I sometimes use the term a research program. As I mentioned before, most people don't do one study on a subject and move on to something else. Some people spend their entire careers in one very specific area even, and they continue to flesh out and develop, and they'll look at it from all different angles, so that over time they're building up this entire body of knowledge regarding this construct that really gives them a better grasp from all different angles, as opposed to someone who studies it just once and operationalizes that construct in just one way. So not just across studies, but within a single program of study, an individual or a group of researchers, you're going to see a utilization of lots of multiple methods. Even within one study, sometimes you'll find that they'll utilize multiple methods so they can compare them to one another. They can look for, sort of concurrence between them. That's another way in which we can argue for validity in our study that we'll discuss a little bit later. So there are different levels of measurement. This is sort of a semantic issue that you need to understand in terms of how we go about operationalizing constructs into these things that can be measured. So measurement is specifically the process by which we apply numbers, we apply mathematics to designate objects, events, and this is according to some objective rule that we apply. So we're taking something which is arguably a construct, which does not exist, quote unquote, in the material world, and we're applying numerical value to it in the process of measurement. The way that the numbers are used to represent a particular scale or level of measurement is really important because it affects a lot of things. Sometimes which one you choose is driven entirely by logic, by how that variable breaks down in our thinking and how it makes sense to apply a certain type or level of measurement as opposed to another. It also has a really large impact on what type of statistical test you can run. Certain types of tests require certain levels of measurement, certain types of data, so to speak. But there are four basic levels of measurement that we're going to discuss in this class and that you see in the research field. And those are nominal, ordinal, interval, and ratio. Exhibit 5.1 in your book shows these levels of measurement. We're going to talk about it in a second. But very quickly, and then we'll go through each in detail. Nominal is essentially categorical. Okay. There's no real numerical value whatsoever. It's simply just a label that we put, a number we apply without significant meaning to distinguish one thing from another within that variable. This can include things like dichotomies, on and off, right? Something about people that can be one thing or the other. You're not saying that, this thing is greater or better than the other. What you're saying is, I'm just going to designate one of them is 0 and one of them is 1, or one of them is 1 and one of them is 2. So dichotomies are one way you see nominal variables. Traditionally, of course, we don't think about gender the same way we used to. We think about gender as being more along a dimension. But if you go back in sort of our older understandings of how we represented gender in our culture, we often really did break it down into male versus female, right? So this is something that's changed over time as we've developed a more nuanced understanding about gender and gender fluidity. But if you go look at research from 30, 40, 50 years ago, of course, what they're generally going to do is they're going to say, okay, in this study, we are interested in how gender affects something, right? We think that males and females are going to differ on visuospatial processing speed, whatever it is you're studying, right? You might say, I think gender matters here. So you're going to gather that information from the individual. Again, this is a more traditional, old-fashioned view of male versus female only as the options. You ask the person, do you identify as male or female? In fact, in the old days, you wouldn't use the term identify. You would just ask, what is your gender? And the person would then say male or female, okay, presumably. Again, I'm trying to be inclusive in modern understanding, but this is kind of a classic example of a nominal variable, how it was used. You then would apply a numerical value to male or female when you would run your analyses, right? It's nominal. It's just name only. So I might say, female is 1 and male is 2, or female is 0 and male is 1, whatever. I'm going to apply just some nonsensical, non-meaningful number just so I can differentiate them in terms of my analyses. There's no ranking. One is not higher than the other. Okay, so that's the nominal level of measurement. Ordinal is where you rank things on a scale. And so there are numerical degrees of difference between these things, but the distances are unequal. And I want you to think about ordinal. A good example of this is, for example, in a foot race, right? If you have 10 people that are running the race, someone comes in first, someone comes in second, someone comes in third, someone comes in fourth, right? So on and so forth down to 10th. Now, the person who comes in first might win the race by a hair, or they might just blow everyone out and win it by a quarter mile, right? So the idea is the distance between those ordinal ranks is unequal. It's not regimented. It's not structured. Everybody could be really, really close the entire time, and they could all be within milliseconds of one another, right? You could even technically have ties, right, in ranking. But essentially, an ordinal level of measurement is just that. It's a rank. First place, second place, third place, something like that. There are numerical degrees. One is higher than the other, but the distances between those numerical degrees are unequal and not necessarily meaningful for how you're measuring it. You don't know anything about the distance between. You just know whether the person came first, second, third, so on and so forth. So these are moving up kind of in mathematical complexity to an interval level of measurement. An interval level of measurement is one that works upon a traditional numerical value. So there's equal distance between ranks on a numerical scale. What isn't significant about an interval ranking, though, is that there is no true 0 point. There's no absence of whatever that thing is. Okay, so essentially what we're thinking here, and we'll talk about each of these in detail more, is the idea of now we have, equal distances between each numerical value, but there's no true 0 point or absence of that thing. One step up on that is the ratio level of measurement. That's where there are ranks with equal distance. There's a true 0 point, which means the absence of that quantity. And we're going to talk about each of these and give examples on subsequent slides. So coming back to the nominal, this can also sometimes be referred to as the categorical, the qualitative. If you think about the root of the term nominal, it means name. You're just applying a name value to this thing. So variables at this level have no mathematical meaning. They vary in kind, quality, rather than quantity, okay, not in amount. Occupation, state of residence, favorite color. Okay, if these are variables that are important to you, if they tie into your theory somehow, for example, if you're studying something about people's perspectives on certain psychological issues, and you think that whether or not they live in sort of the old Confederate South versus the North or whatever, then you might want to know what state they live in, right? If you want to know something about people's occupations, you're not saying that lawyer ranks above school teacher, right? That it means something. It's just a number you're applying to it. So you might have categories of occupation that you then apply a numerical value to. The numerical value is only applied so that you can run statistical analysis. It's just there to differentiate them, but it doesn't mean anything. One important thing to remember about a nominal level of measurement is it has to share two characteristics. Okay. The attributes must be mutually exclusive, meaning that you can't fall into more than one category. You have to be one or the other. This is for to have any meaning whatsoever, that you can only apply one nominal value to that category. And they have to be exhaustive. So whatever it is you're measuring, you have to have an option. You have to be able to be classified into one category or another. Okay, so that's what really characterizes a nominal level of measurement. And of course, what you often see is that there are dichotomies that are measured this way. If you're asking people for like things, of course we all know these things are along dimensions, and people do sometimes fall in the middle, right? But there are certainly things we can think of where you're this or that in some way or another. So, for example, you could look at things like political affiliation, eye color. These are all just kind of things that you can put into categories, but you have to make sure that there's someone that can fit into each. But dichotomies are very commonly utilized as psychological research variables, and it's really the presence or the absence of an attribute. And we've talked about gender as a sort of an antiquated example of this, but really it's just a mathematical score that represents this sort of cutoff that distributes things into one or the other. And as I mentioned, there's this old-fashioned way of thinking like you're coding 1 for male and 2 for female, but there's no arithmetical meaning to that value. So the next level of measurement is the ordinal level, which I like to think of as just sort of rank order, greater than, less than. You've all seen a Likert scale before, a Likert scale, which is like, here's a statement about a proposed policy for the Student Medical Center. How favorable are you towards this scale? And it might have 0 to 7 or 1 to 7, and 1 is not at all favorable, 7 is very favorable, and there's like sort of qualitative values, moderate in the middle, ambivalent, whatever. But those sort of classic Likert scales is a rank order. The Payne scale, which is used, is often thought of as a rank order because it is subjective. It doesn't apply to any actual measurement. Again, it has to be mutually exclusive and exhaustive. You have to be able to put yourself in one rank position or another. You can't fall into multiple positions, and it must cover that whole characteristic in some way. So that's what it means by exhaustive. In the research, one of the research we talked about in this chapter, the Keys research, they used a scale of rank ordering. Rate your life overall these days on a scale ranging from 0, worst possible life overall, to 10, best possible life overall, right? There's no numerical value to a 6 versus a 3. We just know that one is higher than the other. There's no like meaningful value per se. It's really just something that we're applying to rank things along a scale of some degree. It does not assume equal distances between the values, right? So we talked about the race where the person could just blow everybody away and win by a mile. That person is first. Whoever crosses the line next is second, and maybe there's somebody right behind them who's third. There's not equal distance between the rank orders. Things like your grades in class are examples of a rank. Now, of course, we do apply numerical value for things like GPA to that, but if you think about it, A's, B's, C's, D's, F's, that kind of thing is an example of an ordinal level of measurement. Military rank. Within the military hierarchy, there is, private, corporal, sergeant, and, you have non-commissioned officers, then you start the officers, and then you have, lieutenants, you have first and second lieutenants, so on and so forth. People rank, a major outranks lieutenant, for example. So there's no understood, equal distance between those ranks. We just know that one supersedes the other. Socioeconomic status is another. We've kind of gotten away from this, but there used to be much more focus on lower class, middle class, upper class, this idea, which is really just a reflection of your salary or your wealth. But socioeconomic status, of course, does not imply that one's better than the other. It's simply just a measurement, and the distance between them can be quite great. Where we draw that line is important, but you might find that someone says, well, I don't find that very satisfying way of understanding someone's personal wealth or how much they make. I'm just going to use their actual salary, their take home, their gross, whatever. So there are ways you can go up in the level of measurement if you feel like ordinal doesn't really capture it. A key limitation to the ordinal level of measurement is that you cannot assume that respondents perceive the differences between the response scale points as equidistant. So you really it requires the person to project quite a bit of their subjectivity into that scale, and that can be a problem. So the next level of measurement we need to discuss is the interval level. One thing to keep in mind is that all of these levels, as we go up the scale, they share all of the qualities of the scales that come before them. So one way to think about that is we mentioned the idea that they need to be exhaustive, that they need to be exclusive, mutually exclusive. So those are characteristics that are held at every level going up from nominal, ordinal, and then also interval. A good example of the interval level of measurement is the Fahrenheit measure of temperature, okay, or IQ score. So remember, this is one that has numerical distinction. There's equal levels between each numerical distinction, numerical label within. So 1 is equally greater than 2. I'm sorry, 2 is equally greater than 1. 3 is equally greater than 2. So it goes so on and so forth. The reason why we use Fahrenheit as opposed to Celsius is because the Fahrenheit scale does not have a meaningful 0 score, right? Remember that 0 on the Fahrenheit scale is 32 degrees below freezing. It has no qualitative or, it's not the absence of temperature in a meaningful way. We'll talk about Celsius in a moment on the next slide. IQ score, there is no 0 IQ score, right? There's no 0 point. If you take an IQ test, you will score higher than 0. As long as you can respond, essentially. But the 0 is not a meaningful measure within the IQ score, any IQ score scale. So an IQ score of 110, however, is 10 points higher than an IQ score of 100, which is 10 points higher than an IQ score of 90. Those intervals are meaningful, and they are equally meaningful across the scale. But as I said, there's no true 0 point within the Fahrenheit scale. So what that means is that the distance between them, ratio measurements don't make sense. And we'll talk about ratios in just a moment. So for example, 80 degrees in the Fahrenheit scale is not twice as hot as 40. So think about that for a moment, right? When we talk about ratios, we can compare things in that way. In a ratio scale, which we'll discuss in a second, 100 is twice as good as 50, for example. So the ratio level of measurement, again, has all the qualities of the ones that precede it, nominal, ordinal, and interval scales. But what distinguishes it is it does have the true 0 point, which represents the total absence of that attribute or value. Height, for example, there you can, something can have a height of 0, right? If it's entirely flat. We'll get into the physics of that, for a moment. It can be absolutely flat, but you get my point. Running speed, if you're not moving at all, the speed that you're running at is 0, and that is a meaningful. the Kelvin scale actually has, absolute zero, which is where, atomic motion ceases, right? It has a meaning that is referenced in that way within the scale itself. Now, once we're operating with a ratio scale, we can do all kinds of arithmetic procedures that you can't do with the preceding scales. You can do things like adding and subtracting, multiplying and dividing. Those things don't make sense with the interval, ordinal, or nominal levels. They only apply when you're talking about a ratio level of measurement. And as you can imagine, that also has very serious implication for how you are going to run statistical tests, which tests are valid or appropriate. For example, using this, a height of 60 inches is twice the height of 30 inches. A person 30 years old is 15 years older than a 15-year-old, right? There's a 0 point on age, for example, and that's a ratio level of measurement. So when you compare these things to one another, there's a few ways in which we can break them down, and we're going to look at that in the next slide. So ordinal, interval, and ratio levels of measurement are considered quantitative. Okay, so they are mathematical in that sense. They can be applied to various mathematical operations, some more than others, right? Remember, you can't multiply and divide, add and subtract, but you can do certain things to them mathematically that make sense. The level of measurement that you use is really based on how you're operationalizing your variable. So when you assign that operational definition to a variable, it's going to often dictate what level of measurement makes sense. And as I mentioned before, the type of scale that you use really affects the type of statistical analysis that can be conducted. And so that's why measurement level matters in one way. There are two major types of statistics that we utilize within, behavioral research and psychology, and those are non-parametric and parametric. And we're not going to get into too much detail on these, but what I want you to understand about them, at least for the purposes of this class, is that non-parametric statistics are generally applied to the first two lowest levels of these scales of measurement, nominal and ordinal. An example is what's called a chi-square. That symbol there is the Greek for chi. For those of you that are not in the Greek system, that's a chi-square. It's a test of a non-parametric test, a statistical analysis we can do on variables that's really only applied to nominal and ordinal scales. As opposed to that, we have parametric statistics, which are generally used with interval and ratio scales. The most common ones are what are called t-tests and ANOVAs, or analyses of variance. These are examples of parametric statistics, and I'm going to utilize a figure here to kind of make this distinction. So as you see here, remember that each level of measurement contains the characteristics of the other. I think this visually helps to explain that. We start in the bottom left corner with nominal, we go up to ordinal, interval, and ratio. So it's increasing the complexity and the significance. One might argue, the meaning of the level of measurement as we go up. But there are various reasons why we can't utilize, or we choose not to utilize, a ratio scale, for example. It might be what we're studying doesn't make sense. If I'm studying things like gender, maybe there's not a ratio scale that exists for that. Maybe I can develop, as opposed to the old-fashioned nominal male or female with a more nuanced and modern understanding of gender, I may be able to come up with some sort of ranking or ordinal scale, or even like a Likert scale that makes sense, a dimensional scale, but it's still not going to be a ratio. It's not going to have a 0 point, for example. That particular construct that I'm interested in does not lend itself to that level of measurement. So nominal is essentially is a qualitative measurement, level of measurement. Ordinal, interval, and ratio we can think of as quantitative, right? Numerical values that have some degree of meaning, increasing degrees of meaning as you go up into ratio, and things you can do to them. Statistically is really split into two and two. You've got the nominal and ordinal levels of measurement, which you can see there are really for qualitative data, and you utilize non-parametric tests. And then parametric tests are used for more quantitative types of data, which is interval and ratio. What's a little confusing here is that it labels ordinal as qualitative. Your book is going to kind of make a split argument on this, but when you think about it, interval and ratio are the ones that we think about mostly, along with ordinal as quantitative. But when you think about the type of test, we're going to call it qualitative data, okay? That non-parametric test. There's a section in your book which is sort of distinct, but it does make sense to have it here, which is the concept of psychometrics. This is a particular field of study within psychology that really looks at objective measures of psychological testing, things like about the mind and mental processes. But this is really a field that utilizes intense study of measurement to kind of come up with meaningful scales about things that are somewhat abstract. So, an example that you're all probably familiar with is the SAT test. This is measured to predict college success, as you well know. An IQ test is intended to measure intelligence. These are things that psychometrics or psychometricians, people that study psychometrics, really focus on. The most common IQ test these days is the WAIS-4, which is the Wechsler Adult Intelligence Scale. There's also the Stanford Binet. There's several other IQ tests out there, but this one is the most widely used. And the IQ test, and specifically the Wechsler, is a textbook example of this psychometric approach to test construction. It utilizes an examination statistically of measurement to sort of build the test and refine the test and to get it into a form that they feel captures this construct really well. Like any measurement, though, a psychometric measurement can only capture part of the construct, right? So an IQ test only captures a piece of this larger hypothetical thing we call intelligence. There's been a lot of discussion in recent years about emotional intelligence, right? People's ability to empathize, people's ability to read emotional cues and signs from others to be more intuitive rather than, deductive and logical. So it's one of these things we try to emphasize because there's plenty of people that do very well on IQ scales, but are completely lacking in emotional intelligence or in social skills, other things that are valuable but are also understood as part of intelligence in many ways. We also know that culture can deeply affect things like psychometric tests. There's obviously a long history of issues with cultural bias within the IQ test. What psychometricians and what psychometrics focuses on a lot of times is trying to standardize these tests. So it's based on the idea that people have certain levels of a psychological trait and that these levels can be measured. And what it requires is what's called standardization of both the test administration and the scoring, which is trying to limit bias, right? Standardization means that the processes, the procedures are performed exactly the same. If you go to, get a higher education in psychology, at some point you'll be trained to administer an IQ test. It's a pretty standard part of our training and assessment. Some people do it, most of you will do it in graduate school. If you do graduate school, you do it as part of your internships. That's when you're doing your clinical work, you do a lot of assessment and testing. Some people don't do a lot of assessment later on in their careers, myself included. I do it occasionally, but mostly it's something you get trained in, and you learn how to administer it in a very rigorous and regimented way, very consistently the same every time in an attempt to, by standardizing it, to limit the introduction of bias. So in constructing a test, the researcher first has to identify what's called a standardization sample. This is hopefully a large random selection of people that are drawn very carefully from this specifically defined population. And then the tests are administered and scored in a very predefined objective way, and you establish what are called norms based on this sample. And they can include things like the mean, the standard deviation. We have various ways in which we can describe the outcomes of these tests, but let me give you a couple of examples. There's a test that I do utilize a fair amount called the Repeatable Battery for the Assessment of Neuropsychiatric Status, or the R-bands. The R-bands is a very, very common test for cognitive functioning. So if you're examining someone for the presence of dementia like Alzheimer's or vascular dementia, for example, it's very common to give them an R-bands test. What the R-bands test does, which is very interesting to me and very useful, is that the developers of the R-bands test in standardization went and got huge samples of people that they determined did not have dementia by other means. They used a standardized, specific and objective way, as objective as they could be, to say this quote unquote normal sample doesn't have dementia. And they got people of all kinds of age ranges. So they identified that quote unquote normal sample, they gave them the test, and they built up this large data set of how normal people within age ranges perform. So it's standardized in that way. And what it gives us is averages, means for individuals within each 10-year age range, like 81 to 90 or 71 to 80. what's great about that is that when I give that test to a 77-year-old, I can compare them to a normative sample of their peers. And I can say this person falls in the first percentile, meaning 99% of these quote unquote normal 71 to 80-year-olds performed this way, which is like, that's a pretty strong indicator that there's some impairment in functioning. So normative samples are really useful. The other example I want to use is, of course, the IQ test, the Wechsler. The researchers in developing the WAIS-4, they identified a stratified sample, and this is by randomly selecting from uniform subpopulations, which are called strata, and they sort of tried to get a really representative sample of lots of different people. And then this gave us the norms. And so, for example, on the WAIS, 100 IQ is considered average, sort of right smack dab in the middle of the bell curve we're going to discuss in the next section of this lecture. And it also develops a standard deviation, so we know that depending on how far away you are from that mean, we can derive something meaningful about where you fall within the quote-unquote normal population, and we'll talk more about that during the next part of this lecture.